Good morning, class. Welcome to another straight to the point video. This video is about the power rule of exponent. The rule goes as follows. When raising monomials to a power, multiply the exponents. So, and that's the rule as written algebraically. So, a to the power of n raised to a power of m is equal to a to the power of n times m, right? So when you have a power raised to another power, you just multiply the exponent. Okay. So since I want to keep this video short, I'll go straight ahead through the examples, right? So example number one, right? We have uh, 5 cube times 5 square raised to the power 3. So what we want to do is distribute the exponents. So that would be 5 to the power 3 times 3. I'm multiplying the exponent right here. 3 times 3, okay, times 3 to the power of 2 times 3. So I'm multiplying these 3 by each one of these exponents inside the parentheses. So 2 times 3. Okay. So that would give me um, 5 to the power of 9. 3 times 3 is 9. Times 5, 3 to the power of 6. Because 2 times 3 is 6. Now, I could go further, but 5 to the power of 9 times 5 to the power of 6 is a huge number. It's over 100 million. So it's actually simpler to just leave it this way. So I'm going to stop here. Okay. So let's go to example number 2. Okay, so uh, x to the fourth power times y cube all raised to the power of 5. So again, applying the rule, okay, you distribute the exponent to all exponents that are inside the parentheses. So that would be 5 times 4, that's 20. So x to the power of 5, 4 times 5, or 5 times 4. This is multiplication. Okay. Uh, and y to the power of 3 times 5. 3 times 5. Okay. So that will give us x to the power of 20. 4 times 5 is 20. And y to the power of 15. 3 times 5 is 15. And then we are done. Okay. It's just about applying this rule. Whether you have one variable inside or more than one, right? Here, for example, we have x and y inside the parentheses. Okay. Now, example 3, uh, we, ha we have several variable and a number. Now, notice that 2 and 0 right here, you don't see any exponent on them, but the power of 3 is on all of them. If you don't see an exponent on any item inside the parentheses, okay, the exponent is 1, right? So you can put 1 wherever you are not seeing exponents so that you know to multiply, that you are actually multiplying the exponent that is outside of the parentheses by 1, right? In the case of 2 and z. So now 3 times 1, okay? We are distributing the exponent. I'm just applying the rule. 3 times 1 is 3. So that's 2 cubed, okay? 3 times 7, that's 27. 21. So x to the power 21, okay? 3 times 4, that's 12. Y to the power 12. And 3 times 1 again, that's 3. So that's z to the power of 3, or z cubed. Now, so 2 cubed is 2 times 2 times 2, that's 8. So that's a small number enough. So I'll just go and simplify further. So that's 8. 2 cubed is 8. So x to the power 21, y to the power 12, and z cubed. Okay, and this would be my final answer. Okay. As always, you can stop the video anytime and see if you can do the work first and then play the video and see if you got the answer correct. Okay, let's move on to example number 4. Okay, so you may notice that 5 and y are not inside the parentheses. Therefore, this 6 right here, exponent, okay, will not apply to them. Okay, the exponent only that is outside only applies to the items that are inside the parentheses. So I will write 5 and y as it is. Now I can distribute the exponent to with the exponent that are inside. So 6 times 8, that's 48. So x to the 48. Okay, that's a 8 right here. So, and 6 times 2, that's 12. So y to the 12. Now, um, if you haven't watched the video on uh, the product rule of exponents, go ahead and do so. But we have y right here and another y right here to the power 12. So we are not done simplifying it. We can apply the product rule and combine them, right? 5 is the only number, so we are going to write 5 as it is. So y to the 1 times y 12. So the product rule suggests that we add the exponents. So 1 plus 12, that's y to the 13, right? So let's write the x first, to the power of 48, and y, okay? 12 plus 1 is 13. So that's applying the product rule. That will help us simplify this fully. Now we are done, and this is our final answer. Now, I added the example 5 to make you aware of some non-example, right? So remember what we just said right here, okay? Where are you going? Okay, I just made. So this rule apply on for monomial, right? That means uh, you don't have addition or subtraction between the elements, right? So that's one term's polynomial, okay? Everywhere that you see, right, is just one term, okay? So once we start having plus or minuses separating the terms, they are no longer monomials. So you cannot just distribute the power right here. This is not a square, okay, times b plus b square, because this right here is a plus, okay? So it need to be a product inside for you to distribute the exponent. So same right here. So the rule that we talk about here does not apply to these two. Okay, these are special product that we call perfect square. Okay, product of a binomial by a binomial. So that's this particular one I call perfect square, right? So this is actually equal to a plus b times a plus b. All right. And if you expand this, you are going to get a square plus 2 times a times b plus b square. Okay. And this is known as a perfect square. So you have another perfect square right here. All right. And this is equivalent to a minus b times a minus b. Okay. And we expand that as, let me get some space. We expand that this way as a square minus 2 times a times b plus b square. Okay. So um, these two are non-example. I will stop here so that I don't make the video too long. If you have any questions in class, I will answer. So we are going to go ahead and stop right here. And have a good day.